Good day, Mom. I'm Rosa Uba from BSEE 1A. So, number 1. What is a fluid? In physics, a fluid is a liquid, gas, or other material that continuously deforms under an applied shear stress or external force. They have zero shear modulus, or in simpler terms, are substances which cannot resist any shear force applied to them. Also, it is a substance as a liquid or gas that is capable of flowing and that changes its shapes at a steady rate when acted upon by the force training to change its shape. So continuation, so the problem set number 2, example 4.14.1 rather. What force must a dome withstand? So consider the pressure, the force acting on the dome retaining a reservoir of water, figure 14.7. Suppose the dome is 500 meter wide and water is 80.0 meter deep at the dome. As illustrated below, A, what is the average pressure on the dome due to the water? And for B, calculate the force exerted against the dome. So, given H, which equals to 80.0 centimeter, and for L, which equals to 500 meter, and P, which equals to 10 cube kilogram, and for gravity, which equals to 9.81 meter per second squared. A, so the solution for A sa tan, no? So, ang gipangita is what is the average pressure in the dome due to the water. So, the formula is P, which equals to H over 2 PG, which equals to 80.0 meter over 2, which is our deep, and 10 cube kilogram which over m cube, which is our density, and 9.81 meter per second squared, which is our gravity. So that ato na siyang i-times lang. So 10 cube kilogram over m cube times 9.81 meter per second squared. So that ato na gyapon siyang by simplifying, so that 3.92 times 10 to the raised power of 5 Newton per meter squared. So, scientific notation to nato. So, mao to tong pag ato ang scientific notation. So, mao to tong makuan nga answer katong 3.92 times 10 to the raised power of 5 and meter per second squared. So, at by kuan na dili na nato siya scientific notation. So, ato ang average pressure of dome, which is 392 Pascal. And for B, which is atong pangitaon ani, is calculate the force exerted against the dome. So the force, before ato ni siyang makuan, is ato sa pangitaon ang area, which equals to, ang formula is area equals to HL. So equals to 80.0 meter, 500 meter, which equals to 4.00 times 10 to the raised power of fourth power meter squared. So by the force is P Pascal and times area, so that which equals to 3.92 times 10 to the raised power of 5 Newton meter squared times 4.00 times 10 to the raised power of 4 meter squared. So ato ra gyapon ni siyang scientific notation. So mao ra gyapon to ang ato ang ma-answer, ato ang makita nga answer. So that 1.57 times 10 to the raised power of 10 Newton. So kaning 3.92 times 10 to the raised power of 5 Newton meter per second, mao to ato ang average pressure of dam. So ato ra ni siyang i-simplify ang 4.0 times 10 to the raised power of 10 to the fourth power meter squared. So mao na siya tong makita ang answer. So let's proceed to the problem set number 3, example 14.3. So calculating force on wheel cylinders, Pascal paths on the brakes. Consider the automobile hydraulic system shown in figure 14.18. Suppose a force of 100 Newton is applied to the brake pedal, which acts on the pedal cylinder acting as a master cylinder. Though a lever, a force of 500 Newton is exerted to the pedal cylinder. Pressure created in the pedal cylinder is transmitted to the four-wheel cylinders. The pedal cylinder has a diameter of 0.500 centimeter and each wheel cylinder has a diameter of 2.50 centimeter. So by calculate the magnitude of the force F squared or F2 created each of the wheel cylinder. So that para makuha nato ang magnitude sa force, which is ato ang pangitaon ang given and equations. So the given below is F1 which equals to 500 Newton or F2 which equals to F2 which is ato ang pangitaon, and then A1 which equals to 0.500 centimeter, and for A2 which equals to 2.50 centimeter. So solution, so that the equation or the formula is F1 which over A1 which equals to F2 over A2. So that F2 which equals to A2 over A1 F1 which equals to 1 pi r squared 2 and pi r squared 1 F1. So that ataragya pa niya siyang by simplifying 1.25 or 1.25 centimeter squared over 0.250 centimeter squared times 500 Newton, which is makakuha tag answer nga F2. So that ato ang gipangita diba kay katong calculate the magnitude of the first F2 created each of the wheel cylinder. So ato anang dayong makita nga ang F2 which is 1.25 times 10 to the raised power of 4 Newton. And continuation for the problem set number 4, example of 14.4, calculating the average density. Suppose a 600.0 kilogram a woman floats in a fresh water with 97.0% of her volume, submerged when her lungs are full of air. What is her average density? So given. So R which equals to 97.0 centimeter, not centimeter, percent, 97.0%, and P person, so atong pangitaon ang person. So average, ang sa kuan manggid pangutana is pangitana to ang average density sa woman or sa girls. So that PF which equals to 10 cube kilogram over m cube. Solution. So fraction submerged which is POBG, objective which equals to PFI. POBJ equals to P person equals fraction submerged PFI. So P person which is 0.970 rather times 10 cube kilogram over mg cube. So that ataro ni siyang kaanon 0.97, so which is the volume, and times the density which is the 10 cube kilogram over mg cube. So mana siya tong density, so that by simplifying and ato ang using the scientific notation or pwede ra gyapon siya edit so that P person which is 970 kilogram over m cube. For problem set number 5, example 14.5, calculating the fluid speed through a nozzle. A nozzle with a diameter of 0.500 centimeter is attached to a garden hose with a radius of 0.900 centimeter. The flow rate through hose and nozzle is 0.500 L over S. Calculate the speed of the water. And for A, and the hose, and for B, and the nozzle. So, given Q, which equals to 0.500 L over S, A1, which equals to 0.900 centimeter, and for A2, which is 0.500 centimeters. So, atong pangitaon ang V1 and V2. So, solution. Solution for the hose. Atong pangitaon una ang katong calculate the speed of the water in the hose. So, sa hose ni siya, then, before dayon ani is ato pong pangitaon ang speed sa nozzle. So, before that, ato sang unahon ang speed sa water sa hose. So the equation or the formula, which is the V which equals to Q over A, which is area, and equals Q over pi r squared 1. So that 0.500 L over S and 10 cube meter cube over L over 3.149.00 times 10 cube meter, negative 3 to the raised power negative 3 meter, rather not cube. So, kani siya, ito na ni siyang i-substitute sa, mao dayon ni siya ang katong makita, ato na ni siya i-substitute do. So, makakreate og final answer nga V1, which equals to 1.96 meter per seconds. So, kani di ay ang V1, which is ang kakusgon sa ato ang tubig. So, speed man, so kakusgon. Kakusgon sa atong tubig nga naa sa hose. So, ang gipangita biya kay is calculate the speed of water and the hose ra ni siya, not for nozzle. So, for A pa man ni. So, ato din proceed sa letter B. So, kato na tong calculate the speed of the water and the nozzle. So, using the formula A1 V1, which equals to A2 V2. So, V2, which equals to A1 over A2 V1, equals to pi r squared 1 and pi r squared 2, which equals to R1 squared over R2 squared V1. So that 0.900 centimeter squared over 0.250 centimeter squared. So, given na siya. So, ato na siyang i-copy. And then, times 1.96 meters per second. So, V2, so, ang iyahang kakusgon sa tubig sa nozzle ay not lagi tubig sa nozzle is 25.5 meter per seconds. So, let's proceed to the problem set number 6, example 14.7, calculating the pressure of fire hose nozzle. So, fire hose use any major structural force having side diameter of 6.40 cm, figure 14.33. Suppose such hose carries a flow of 40, which equals to 0 L over S, rather, starting at a gauge pressure of 1.62 times 10 to the raised power of 6 Newton per meter squared. The hose rises up 10.0 meter along a ladder to a nozzle having an inside diameter of 3.00 centimeter. What is the pressure in the nozzle? So, given Q, which equals to 40.0 liter per seconds, and A1, which equals to 6.40 centimeter. And for A2, which equals to 3.00 centimeter, and P1, which equals to 1.62 times 10 to the raised power of 6 Newton per meter squared. So, solution by the Benedictus equation. P1 plus 1 half P4 2, which over 2 over 1 plus PGHI PGH1 rather, which equals to P2 plus 1 half PV2 squared plus PGH2. So first find the V1 and V2. Since the Q which equals to A1 and V1, so the V1 which equals to Q over A1, which equals to Q over pi r squared. So that ang 40.0 times 10 to the raised power of negative 3 meter cube per seconds. And over pi r 3.20 times 10 to the raised power of negative 2 meter per seconds. Meter squared rather. V1 12.4 meter per seconds and V2 56.6 meter per seconds. And for the P2 which equals to P1 plus 1 half P V1 squared minus 7 2 is V2 squared PGH. So that P2 which equals to 1.62 times 10 to the raised power of 6 Newton per meter squared plus 1 half. So that 1000 kilogram per meter cube and 12.4 meter per second squared minus 56.6 meter per second squared. So ito rin siyang simplified. Negative 1000 kilogram point meter cube and times 9.80 meter per second squared times 10 to the 10.0 meters. So kani siya to R ni siyang kani kay gipangita man to ang pressure and unsa daw ang pressure sa mga nozzles and mao na yung final answer nga walay makita nga pressure sa nozzle. So P2 which equals to 0, so pressure in nozzle, so 0 ang nozzle. So that would be all. Thank you.